Once again, welcome to my lecture in this YouTube channel. As you know, now I am discussing mostly the postgraduate topics. Recently, I have had 4 lectures. First one was overall meat quality on different aspects like microbial quality, physicochemical quality, nutritional quality, sensory aspects, briefly altogether. I had a similar lecture for undergraduates long back that was very precise, and then I had 3 lectures related to fresh meat quality. There was a fresh meat quality 1 and fresh meat quality 2, and the factors important role have on the fresh meat quality. So I have mentioned earlier there are different aspects of quality of meat. Now we are going to focus today on the composition and nutritive value of meat. So in this lecture we will discuss more details about the chemical composition of muscle or the approximate composition, and in different species we'll little bit discuss about the detail component like water, more details on protein and different aspects of meat protein, in details about the lipid, these are the most important, and then we will discuss also about the vitamins and minerals and some of their important role in the human nutrition. So here is a brief introduction about the composition and nutritive value of meat. As we all know, meat is an important source of nutrient in human diet. So most of the important nutrients required for good health is present in sufficient quantity in meat. So it's a very important component in human diet. It's an excellent source of animal protein with all essential amino acids and micronutrients in proper proportion. So meat protein is very high quality, so it is judged through the biological value because it has got all the essential amino acids in proper proportion, and also it is a valuable source of B complex vitamins. B complex vitamins normally is not available in many foods, so meat is a very good source of B vitamins, and also some of the important minerals like iron, zinc, selenium, manganese, even copper, cobalt. So all these things are very important, and meat is a good source of them. As I mentioned, biological value of protein from meat is very high. That depends on the distribution of the essential amino acids, and it is a important micronutrient essential for good health, and most healthy balanced diet include lean meat. Here we will see the chemical composition of muscle, that is the raw muscle. As we all know, the major component is water, which is about 75%, and then protein altogether it is about 19%. It may vary from 18 to 21% depending on the species and muscle. So this protein is of 3 categories. First is myofibrillar protein, which is about 11.5%, which includes the myosin, actin, tropomyosin, troponin, titin, connectin, and there is sarcoplasmic protein, which are mostly of soluble type, 5.5%, which includes myoglobin and glycolytic enzymes, and the third variety is connective tissue protein, around 2 to 2.5%, mostly present in the connective tissue covering on the muscle, which includes collagen, elastin, reticulin, and little bit of sarcolemma. Then lipids, so in lean meat the lipid is less, it is up to 12.5%. Then carbohydrates 1 to 1.2%, and there is miscellaneous soluble substances in 2 categories, altogether around 2.3%, like nitrogenous substance, creatine or inosine monophosphate nucleotides, and there is inorganic substances like phosphorus, potassium, sodium, magnesium, calcium, zinc, and other trace elements. And there is vitamin, which is in minute quantity, that can be either fat soluble or water soluble. So here we will see exactly the chemical composition or approximate composition of meat. Here it is in 5 important species, that is lamb, pork, beef, chicken, and quail. So lamb represents roughly the sheep and goat meat. So first is the moisture content, that is about 71.5%. In pork also almost similar, in beef also almost similar, in quail also. Only in chicken it is little bit higher side, almost nearing 75%. Then protein, as I mentioned earlier, it is around 19 to 23% range. In case of lamb 19.5, in pork 20.22, in beef 20.94, in chicken it is higher 73.2, and in quail 20.5. The fat or lipid percent on an average, this is for the meat altogether, not lean muscle. So it is around 7% in lamb, 6.75 in pork, 6.33 in beef, 3.5 in chicken. So in case of chicken, protein is little higher side and the fat is little lower side. In case of quail, 5.5. And the ash content around 1% generally. So in case of lamb 1.5, in pork 1.04, in beef 1.03, in chicken 0.8, and in quail 1.20. So in case of chicken, the ash content is little less, fat content also little less. That's why it is having more moisture, and protein also little higher side. And in terms of calorie, mostly it is low in calorie. And if we think of the carbohydrate, it is on an average around 1% or below. The calorie per 100 gram meat is about 145 in lamb, 147 in pork, 147 in beef, 125 in chicken, and 125 in quail. So in chicken it is little less because the fat is less. Now we have mentioned about the different proximate composition. Now, as we all know, water is the major component in meat. Truly water is also a nutrient, but we may not have to get it from meat, but little bit details we will understand about the water present in muscle or meat. As we know, it is the largest component, about 65 to 75% of the muscle tissue, 65 to 75, and this ratio will be higher when the fat content is less, but when the fat content is more, then the water content will be reduced. Now 70% of water of fresh meat is located in myofibril. So we have discussed thoroughly earlier what is myofibril. Much of the water remains in that. Then water molecules are attached with charged groups of muscle proteins. So muscle proteins, mostly myofibrillar proteins. So much of these water molecules are attached with the charged groups of protein. That is the amino group and carboxyl group present in the amino acids. About 40% of the water is tightly bound and impossible to dislocate. So this we have discussed earlier when we were discussing about the functional quality of meat. So at that time we have told about the importance of pH and water holding capacity and how the water remains in the free form and bound form. Thus most of the water remains in free form, that is around 60%. And here the pH has an important role, as we have discussed earlier in UG lecture, that is the change during rigor mortis and further during aging. So pH should go up, then only water holding capacity will increase, and then the water retention will be more. And in other words, when the pH is higher, the water holding capacity will be more, and meat will have a better juiciness, and yield of the product also will be more. Now we will discuss about meat proteins. As we all know, protein is very important nutrient for good health, and meat is a very good concentrated source of proteins, and that's why meat is a very important food in the diet, and it is so costly. Not only that, there are plant origin proteins, but this animal origin protein or the meat protein has got very high biological value. These proteins are rich in essential amino acids, and their deficiency lead to protein malnutrition. So the quality of protein depends on the ratio or profile of essential amino acids. So meat proteins has got very good profile of almost all the essential amino acids in a required proportion. Now, as we have discussed earlier lecture in the UG, that is the different kind of proteins. So myofibrillar and sarcoplasmic proteins are of very high quality. Myofibrillar protein is the major protein in meat, and then sarcoplasmic means the soluble proteins, that is myoglobin and glycolytic enzymes. So all these are very high quality protein. High quality means they have got better distribution of essential amino acids. And the third category of protein is the connective tissue protein, which is coming from the connective tissue layers I have mentioned earlier. These proteins are of little bit lower quality because they are deficient in some of the essential amino acids like tryptophan, sulfur containing other amino acids. Now here briefly I will explain about biological value of protein, because in the previous slide I have told about the quality of protein and one of the indicator is biological value. So let us understand what is biological value. Biological value is a measure of the efficiency of the protein in a food for the maintenance and growth of the body tissues of an individual. So biological value indicates the efficiency of the protein we take as food to have their role for maintenance and growth of body tissues. So generally it is computed as the percentage of protein intake actually utilized in the body. So how much percentage of protein is actually utilized in the body from the total protein we take through the diet, or sometime it is also calculated as the percentage of digestible protein assimilated from a foodstuff. Percentage of digestible protein. Protein is digested. After that, how much is assimilated in our body? That indicates the biological value. So in other words, this biological value depends on the correct proportion of the essential amino acids for us. So here a little bit more we will discuss about the protein in meat. So generally in red meat, the protein content, as we have seen already, around 20 to 24 gram of protein per 100 gram of lean meat. And when we cook it, this protein content increases, that goes up to 27 to 35 gram of protein per 100 gram. So why this increase? Because during cooking, some water will be lost and the cooking yield goes down than the 100%. So naturally some of the water goes down means the yield will be less and it will increase the concentration of protein. In most countries, average protein intakes are far below the requirements. In general, the protein requirement is about 1 gram per kg body weight. The thumb rule is 1 gram per kg body weight, but at least we should have, in case of adult, 55 gram, and in case of women it is 45 gram. Adult men 55 and adult women 45 gram, and of which at least 20 grams should be from animal origin. 20 gram of protein should be of animal origin, because animal origin proteins are having high biological value. Here in this table we will see the essential amino acid composition of important red meat. So red meat, here we have got beef, lamb and pork. And as I told, some of the amino acids which must be supplied through food, they are called as essential amino acid. And in case of human, it is 9. 9 of these amino acids are listed, and we can see here lysine. In both all the three red meat is around 7.5 to 9%. In case of leucine, again it is around 7 to 8.5% range. In isoleucine, it is around 4.7 to 5% range. In cysteine, around 1.2 to 1.5. In threonine, 4.2 to 5.2% in all the three red meats. Methionine, 2.2 to 2.6%. Tryptophan, 1.2 to 1.5%. Phenylalanine, around 3.8 to 4.3%. Arginine, around 6.4 to 6.8%. Histidine, around 2.8 to 3%, and valine around 5 to 5.6%. So these are the 9 essential amino acids in all the three most common red meat, and they are very optimally distributed in all these red meats. That's why red meat is very important in terms of quality of protein. Here we can see a quick look about the ranking of different kind of proteins. As I said, the quality of protein depends on the profile of amino acids, and that quality is judged through three important parameters like protein efficiency ratio, biological value and net protein utilization. But nowadays there is a further modified score, that is the protein digestibility corrected amino acid score. This is a more rational way to compare different protein, and we can see that here the beef is in a very high quality, then casein, egg and milk, they are one, that is the very high. Even soy protein and whey protein also very high. So now next important component in meat is the lipids. We have first seen the major part is water, then next major is the protein, we have discussed in details, and now about the lipids. So this lipids in meat, mostly they are neutral lipids and phospholipids. And neutral lipids are mostly triglycerides. Triglyceride means in the glycerol molecule, three fatty acid will be joined as ester linkage, and these three fatty acid can be same or different. So sometimes they are called homotriglycerides or heterotriglycerides. Now these fatty acids which is forming the triglyceride mostly are saturated and monounsaturated fatty acid in case of meat lipid. But this main saturated fatty acid in case of meat is the palmitic and stearic acid. These are the most common fatty acid present in meat. And in the unsaturated fatty acid, the most common unsaturated fatty acid is oleic, linoleic and linolenic. So they are different in their number of carbon atoms and number of double bonds. So oleic is only one unsaturated fatty acid, that is 16 carbon. Then linoleic is 18 carbon with 2 double bond, and linoleic is 20 carbon and 3 double bond. And then there is another type of lipid, that is cholesterol, which is in minor component but very important. Nowadays the cholesterol propaganda is going on against the meat, which is not fully true, and the organ meats, especially liver, has got more of this cholesterol. Now little more details about the fatty acids in meat. As I mentioned, the major saturated fatty acid present in meat lipid is the palmitic and stearic. So palmitic has got 16 carbon and stearic has 18 carbon. And there are a very minor quantity of other saturated fatty acid like myristic acid, which is 14 carbon, and lauric acid is 12 carbon. In the right side, the unsaturated fatty acid, I said monounsaturated fatty acid. Lean meat has similar proportion of saturated fatty acid and monounsaturated fatty acid. Their proportion is almost similar. And in the monounsaturated fatty acid, that is the carbon number 18 with one double bond, I have told earlier, that is the oleic acid, and that's the major fatty acid in meat. About 30 to 40% of fat in meat is composed of monounsaturated fatty acid. So oleic acid is the major fatty acid present in meat lipid. Now little more about the fatty acids in the health and nutrition. So fat supplies rich source of energy and essential nutrients such as fat soluble vitamins and essential fatty acids. So some of the vitamins are fat soluble, they are supplied through fat, and there is some essential fatty acid like essential amino acids. So here the linoleic, linolenic and arachidonic, these three fatty acids are considered as essential fatty acid. They are also supplied through meat lipid. Now regarding the red meat, when it is lean, it will have almost similar proportion of monounsaturated and saturated fatty acid. So there is a wrong propaganda that it will have only saturated fatty acid. Red meat is having only saturated fatty acid, which is wrong. Similarly, lean meat is relatively higher in polyunsaturated fatty acid and lower in saturated fatty acid compared to untrimmed meat. So whole meat, if we take whole meat along with all the fat, then it will have little bit more of saturated fatty acid. But when the trimming is done, then the polyunsaturated fatty acid proportion increases. So why it happens so? Because the superficial fat, particularly below the skin, visible fat, it is removed. Then only we can call it lean meat. So when the superficial fat is removed, that fat contains higher amount of saturated fatty acid. So when it is removed, the remaining fat is having more of unsaturated fatty acids, which is healthy. Here in this table we can see little more further details, especially the polyunsaturated fatty acid in different species and organ meat, and also the cholesterol. So in the first column left side we can see the cholesterol, which is very less in the red meat, only it is high in the organs like liver and kidney, and it is very high in the brain. Whereas in the right side we can see the other polyunsaturated fatty acid, that is the 18:2, that is linoleic, 18:3 linoleic, and 20:3 arachidonic, and 20:4 further unsaturated of arachidonic, and then there is 22 and 25 double bond and 6 double bond. Now out of these, first, second, third are most common, and these three are essential amino acid. We will focus more on that. We can see all the red meat has got a almost similar amount of this linoleic, linoleic and arachidonic. Sometimes it is more in the kidney and it is more in the liver. If we see the last three line, liver has got very good amount of all these polyunsaturated fatty acids. So these polyunsaturated fatty acids are considered as healthy for us. Here we can see a further comparison of different category of fatty acid in different red meat, because the fat related issues are most common propaganda against the human health and red meat. So we can see here in case of bacon, the proportion, first one is the saturated fatty acid, then monounsaturated, which is good, and then there is N6 polyunsaturated fatty acid, which is not so good, and N3 or omega-3 very less. In case of pork, it is almost in the similar. Then in case of lamb, we can see that total saturated fatty acid is higher, and then the monounsaturated, then the N6 is less and N3 also less. In case of beef, we can see again the total saturated fatty acid is comparatively less than lamb, and the monounsaturated is higher, then N6 is less. So this is an understanding that saturated fatty acid is not the only fatty acid in red meat which is commonly being propagated. So there are sufficient quantity of monounsaturated fatty acid which is very healthy. So here quickly I want to tell about conjugated linoleic acid. Conjugated linoleic acid is a very special fatty acid with a lot of health benefits, and this is mostly available from meat of ruminant origin or milk. So we can see in this table that the content is very high in lamb and beef, whereas it is less in pork, chicken, turkey, because these are monogastric animals, not ruminant. Only in case of ruminant the conjugated linoleic fatty acid is high, and it is also available through milk. So this CLA is a very good source from ruminant meat or milk, and that plays a very important role in our health, especially anti-tumor activity or immunity and many other health benefits. So it is considered as a functional component in meat. We have discussed about it in more details in my other lecture earlier. Now briefly we will discuss about carbohydrates. I have mentioned in the earlier preliminary table the carbohydrate is on an average about 1% or 1.2% in muscle. So muscle has got very little carbohydrate, and all this carbohydrate is utilized in the process of post-mortem changes and pH decline. We have discussed thoroughly there. Due to the anaerobic condition, the all carbohydrate or glycogen undergo the anaerobic glycolysis and produces the lactic acid, and that leads to the decline of pH, and through which we achieve the ultimate pH of meat. And they have an important role in energy metabolism, glycolysis, and also in color and tenderness. So if this proper glycogen storage is there and proper postmortem changes is happening, then only we can get the optimum pH and other postmortem changes or post rigor mortis, the changes related to aging and conditioning, which gives a better quality meat. So presence of optimum amount of carbohydrate during slaughter is very important. Now we will discuss about the minerals present in meat. About 3.5% of total body weight is inorganic matter, and that includes all kind of minerals. So inorganic elements play very important role in rigor mortis, that is the post-mortem changes and other aging changes, tenderization and conversion of muscle to meat and related to pH and water holding capacity. So these minerals has an influence on the color, tenderization and oxidative rancidity. So color is related to myoglobin where we have the iron. Then tenderization has relation with the calcium activated sarcoplasmic factor. So there calcium has a role. And oxidative rancidity, there again different minerals either pro-oxidant or antioxidant. So sodium chloride, it is a pro-oxidant, whereas presence of different other minerals also of pro-oxidant like copper, etc. And then meat is a good source of all minerals except calcium. So calcium is not really present in meat. Of course it is there in bone. So we are telling about the lean meat. Whereas it is a rich source of potassium, phosphorus, sodium and magnesium. Meat is a very good source of iron in easily absorbable form. So generally iron deficiency anemia is a predominant in every society, especially the developing and underdeveloped country and more on the women. So meat is the best source of iron, and this iron is most easily absorbed than the inorganic source of iron. And then it's a very good source of other trace elements, micro elements like copper, zinc, manganese and cobalt. So all these has got very important role in our biological functions. So here we will see a list of important minerals like potassium, copper, iron, phosphorus, zinc, magnesium, sodium and calcium, and it is compared between the red meat. Each variety has got a raw and cooked, chopped mutton and then cooked, beef and cooked, bacon and cooked, and pork and cooked. So all the four variety we can see. Roughly we can see that potassium is in a very high level in all the meat, but it is highest at the bacon. Then we can see the copper, again it is in the range of 0.1 to 0.2, and it is relatively higher in case of mutton and beef. Then in case of iron, again it is higher in beef and equally good in mutton and bacon also. Then phosphorus, in general it is in the range of 150 to 200. It is relatively higher in case of cooked beef and bacon. Then in case of zinc, it is at a low level, but it is required at a very low level. It's a trace element in on an average 2 to 4%, quite high in mutton and beef. In case of magnesium, again it is in the range of 20 milligram per 100 gram, and it is sufficient quantity for human requirement. This is again required in a very less amount. Then sodium relatively less, that is in the range of 7468. It is very high in case of bacon. And then finally calcium. Calcium in general I told it is very less in meat because this is of lean meat, whereas calcium is very high in milk, as we all know. So here little more I want to highlight about the iron in meat. So iron in meat is most bioavailable source of iron, particularly the iron deficiency anemia is very common everywhere, I mentioned earlier, and especially non-heme iron or the inorganic source of iron is not very good for bioavailability. Especially it may have a phytate binding, which is not good for easy absorption and assimilation. So meat and meat products provide a good source of iron for both men and women, and the most vulnerable group is the infants, girls and women due to their reproductive age. So they lose a lot of iron. So in that case the meat origin iron is best for avoiding the iron deficiency anemia. Here briefly I want to highlight about zinc and its role. It's a very important trace element for cell division, growth and tissue repair. It is necessary for reproductive development, immune system and healing of wounds. So meat is a very good source of bioavailable zinc. In UK, it has been reported that meat provides about 34% of the requirement, and there is a great concern about low intake of zinc among the adolescent girls. So zinc is very useful and very important role in the biology, and meat is a very good source of zinc. Briefly, I want to highlight about selenium. Selenium is a very important mineral in a very low level. It has got a tremendous role as an antioxidant and also necessary to use the iodine in thyroid hormone production and also in immunity function. And meat is a useful source of selenium, especially red meat. And in many countries like UK, there is a downwards intakes of selenium in recent years. It has been reported, and so there is a trend of producing selenium rich wheat in Canada and USA, even in European countries. So meat is a very good source of selenium, and selenium is a very important requirement for good health. Now we will talk about the vitamins. The vitamin content of meat is variable depending on species, age, nutritional status and breed. So species wise, age wise, there is a variation in the vitamin content, and as we all know, there is two group of vitamins: fat soluble and water soluble. Water soluble vitamins are localized in lean tissues directly in the muscle, whereas fat soluble vitamins are present in lipids. So meat should have the lipid, meat should have the fat, meat should be not just lean meat, it should have the fat to get the proper nutrients, especially some of the essential fatty acids and also these important fat soluble vitamins. So meat is a rich source of B complex vitamin, I have mentioned earlier, and pork is very good for B complex vitamin, especially the thiamine. Pork has got the highest source of thiamine B1, which is about 5 to 10 times more compared to mutton. Most of the vitamins in meat are relatively stable during cooking. So though we do cooking, but except a few, maybe thiamine and all, rest of the vitamins are quite stable during cooking. And liver is a rich source of riboflavin, niacin and other B vitamins. So liver is the very good source of many of the important fats and also the B complex vitamins. Here is a table about the vitamin content of various red meat, and we can see that in the A, D and E, K, they are the fat soluble vitamins, but A and D are here, they are having in a very low level in all the red meat, whereas B1 we can see that it is highest in case of pork, 1.2, and little bit better in bacon also. Then B2 almost in the same range, around 0.2 units per 100 gram. Then nicotinic acid, it is high in veal, pork, mutton and in beef. Then pantothenic acid, again it is almost in the range of 0.4 to 0.6. Biotin, it is very high in case of pork and veal. Folic acid, it is very high in case of beef, around 9 unit per 100 gram, and in case of veal also it is 6. Then B6, it is little less at the range of 0.3, 0.4 unit, and B12 quite high in case of beef, mutton and in pork. And we can see the last row, vitamin C, which is almost absent in all the meat. So vitamin C is very less in meat, even it is less in milk also. So with this, we are at the end of today's lecture. Today we have discussed about the composition and nutritive value of meat. So we have discussed in details about the approximate composition, and then we have discussed details about the protein, which is most important in case of meat, and we have discussed about different kind of proteins and the amino acid profile, particularly essential amino acid and the biological value of protein and all that. Then we have discussed little details about the lipid, different kind of lipid, essential fatty acid, saturated, unsaturated fatty acid, the false propaganda about the red meat having only saturated fatty acid, that's not correct. And then we have discussed about the important minerals in general, and especially the iron is very important from meat, and also the selenium, manganese, cobalt, all these are very important nutrients from meat. And then we have discussed about the vitamins. As we know, some of the B vitamins are very good source from the meat, especially pork meat is very high in B1, and beef is good for iron and other some of the B complex vitamins. So this is briefly about the composition and nutritive value in very brief, and it is taken from different sources. You can see the different books of my co-authors, which may be useful for you to refer and get further details. Thank you.